Hello, welcome back. So let's summarize what we have done so far. So just the hypothesis. In our previous video we talked about this hypothesis. So in the end we put away something 120 kilos. Honestly, I don't know, just let me know. Okay, then we have a height, we assume a material. Okay, and we're going to do a few simulations now, and these are also our operating conditions. Let's assume initially sea level and then for this velocity. So personal experience, I would say that we're not going to see the critical Mach number, so no shock wave, but who knows, let's go higher velocities. And these are our hypotheses. These are hypotheses. Things are going to get more complicated. Okay, so we have our geometry, we have the feature, and just to talk about as well the tools that we're going to use. So I'm using here space cleans. Okay, here I have different versions and the featuring and so on, but you can use any utility. So I show you that, for instance, you can go and use Onshape, and again, this is a crazy geometry. So I like to have this geometry and not a more organic geometry like STL, because here we have the components, so we can go to precision and move some stuff, but there are many geometries that you can find. Okay, so this is our geometry. Okay, can be modified here. It is easier probably to modify here. Okay, and a little bit that after creating and the computational domain, after creating the mesh, okay, so we have this. Okay, you see that it captured very well the features, but there are some defects here that can give you problems when doing the mesh. Okay, the volume mesh. So here also I have been thinking what tool to use. So let's say SpaceCams and also Fusion 3D. Okay, just to this, we have also Fusion 3D that you can get personal use. You can do the same stuff. I'm more familiar with the SpaceCam, but in Fusion 3D you have the personal license and free as well, and you have also mesh mixer. They claim that all the things that you have here, you have it in Fusion 360, but I will say no, it still is very powerful, so you can smooth and refine your geometry, your STL geometry. But look at that, you have all details. So here I have been playing a little bit, and after the smoothing, see that I eliminate many of those nasty details, so this is much nicer for the volume meshing. Okay, and just look at what we have here in the original geometry, also the things that you need to fix. So this will be nasty for meshing here. No, okay, so basically and it's not that difficult, okay, to do to repair. So after repairing, see that we make it smoother. Okay, here we apply the smooth filter, and then with the filter a little bit the fingers, this can be fixed. Okay, so I have the fixing is not easy here. It will be much easier in mesh mixer, or I will go back to the dreaded Blender 3D, and I will show you why I would like to use it. So since here in the hand, that here you have here this cover, and then you have a hole here. So for meshing, this is not nice. Even you can solve it. So here I was also playing a little bit, so see that after applying some smoothing, I close that hole. Okay, and then that you have that, we can merge this to mesh. So this is the sense that we need to do some cleaning. Okay, to avoid those potential problems that we can have in the meshing. Then talking about the domain, so we have Ironman, and initially we can do, and this is what I recommend, and this is what I'm going to do, and also I will share, okay, a circular domain. Why? Because we need to construct the polar. So we need to run this simulation, and just coming back to our operating conditions. So we go from different velocities, but also different angle of attack. We're not going to go to large angle of attack of 20, whatever. Okay, just 10 will be enough. So it's easier to have it like this. You rotate. I will generate also the rectangular one, but as you see, the rectangular one is not as as friendly as the circular, in the sense that this one you rotate, and you need to generate the mesh here. So you rotate your Ironman. Okay, you need to generate a mesh, or you need to play a little bit with the boundary conditions to change the angles there. So it will be up to you. I will give you both meshes. And okay, so the tools here, I have in this line the tools I'm going to use, and here I talk about the dreaded Blender and why I want to use Blender. Here Blender have very nice sculpting capabilities that also you have in Mesh Mixer. Honestly, I think Mesh Mixer is more user friendly, but what I want to use Blender is because in Blender we have the posing. Okay, we can change the pose of our geometry. So here I already did it. So I did some selection of faces and so on. So later I'm going to show you how to do this. And look at that, how cool is this? So I select here, everything is connected, kind of creating bonds. And now I can move it and I can change pose. Okay, so believe me, this is easier than it looks like. So then go here and I can rotate like this or like this, and probably it will be better like this. Okay, and let me move this one. Okay, so you have to be very gentle now. Sometimes you do large deformations. It's going to give you problems. So, and probably here. So as you see, the moves where sometimes he's flying like this, and then he have some jabs coming from the hand. So this is why I want to use Blender to do this one. So you have some nasty faces here. So I just did some crazy deformation. This is the stuff like you need to do. Okay, but you have to be very gentle when doing these things, otherwise you're going to deform. But this is why I want to use it. But also in the sculpting, when it comes to sculpting, you have many tools. So also you can smooth your surface. Okay, so our design assumptions tools, and talking about the weight. So let's take a look at this video. You know, it's very nice videos this is seeing, so thank you very much here taking for YouTube. So look at that, it's very metallic. Okay, a lot of metallic noise going on. After all, you have the core Ironman in the name. So let's take a look here, and I really like towards the end. So see that all that material going on. So our hypothesis 120 Pro is a little bit too conservative. Okay, that stuff is very metallic. Look at here that we can also get an idea of the thickness. You know, the 2mm hypothesis maybe is true, maybe not. But towards the end, I really like this part. Okay, so when we have the mask here, and then you're going to see that solid here, that solid clamp. Bam. So very metallic. So this is what we want to do. Okay, we have all our hypotheses, and okay, so let's see you in the next video. Also, let me know, what do you think about these hypotheses and assumptions? I might be wrong, I might be right, it's up to you. Okay, so feel free to contribute. So put your comments there in the comment section, and well, see you in the next video. Bye.